Assalamu alaikum. I am glad to be with you on the first international conference on sustainable energy and advanced material in this online forum. What pity we weren't able to reach you because of the COVID, but maybe in the next years or in the next forum of this conference we will be with you. So I am Mohamed from Ain-Temouchent University in Algeria. I have the honor to present to you the main part of my research work in the field of photonic and optical entitled Transmission of Laser Beams in New Generation Optical Fibers. An optical fiber is a very thin glass or plastic wire which has the property of being a conductor of light and is used in the transmission of data and light. Several names of this new class of optical fiber as photonic crystal fiber, holy fiber, or microstructured fiber. These PCF are pure silica fiber. It contains an arrangement of regular air channels that run along the length of the fiber and act as microstructured cladding. A defect in the period structure acts as a core. There is two kinds of photonic crystal fiber. The first is the hollow core photonic crystal fiber, are fibers where the core index is lower than the cladding index. The propagation is by photonic bandgap. The second type of photonic crystal fiber are the full core PCF, are fibers where the core index is higher than the cladding index. The light will be guided by modified total internal reflection, just like in standard fibers. The light is trapped in the core. It is this type of fiber that we will use them during the rest of our studies. There is lots of properties of this photon crystal fiber. Among the properties, mention may be made of the single mode condition. They are single mode for all wavelengths at an effective frequency less than 2.405. The second parameter is the chromatic dispersion. Zero dispersion wavelength is in the range of 0.97 micrometer to 1.12 micrometer. The modification of the geometry parameter makes it possible to design and obtain new properties of optical fibers. If the diameter of the holes is smaller, the dispersion tends towards that of the material. Because the air channels have an insignificant influence and become more important when the diameter of the holes increase. There are several applications of this type of photonic fiber. We can mention coupling and multiplexing. This fiber is achieved by introducing two defects or two cores in the microstructured cladding. We put the light in one of the cores and we can't either get the light in the other core or multiplexing two signals in the same fiber. There is lots of application of these photonic fibers. We can use this fiber also as a sensor, as an example to calculate the number of cars crossing the road. Every time a car crosses the road, there is a pressure exerted on the fiber. Automatically, there is a change in the signal level. Turning now to another research area, it is the transmission of laser beams in new generation optical fiber. The objective is to show the influence of the number of crown and the diameter of the air hole on the ability of photonic fibers to continuous laser beams. The main goal of this study is to show the evolution of laser beams in optical fibers in order to have a maximum transmission signal. The first results show that with three layers of air hole, we have absence of the laser beams at the exit of the fiber due to the diameter of the hole. On the other hand, with 5 layers, a slight spread, and with 10 full spread. Changing diameter now to 0.75, the laser propagates with different power. For the first figure, it reached the third layer of airhole, but with 5 reached the second layer of airhole, and the second one with 10 layers achieve only 1 layer of airhole. The modeling of a photonic crystal fiber whose hole are spaced with 1.5 micrometer required the consideration of 10 crown of air hole with a diameter of 0.45 micrometer and only 3 crown of air hole where their diameter is 0.75 micrometer. As a conclusion, we can say that research on photonic crystal fiber is still very young, and we may expect many new developments, more accurate and efficient methods for designing and optimization. And thank you for your attention.